Welcome back, Eastview Scholars. In this edition of Sharp Shorts, we're going to continue with our stoichiometry discussion. But what we're going to do is we're going to actually show an example and just work through it. What I hope then is as you go to your packet and continue to work through this unit with book problems and packet problems and everything else, is that you find that the process itself becomes rather easy and redundant. Because it doesn't change. The 3 steps are listed right down here. We've had these, we showed you at the end of the last tutorial. And again, just a reminder, stoichiometry, as it says in the definition, is that ability of combining everything we've learned about reactions and moles and atoms and knowing that they combine in simple whole number ratios to make it predictable, to be able to determine what's going to happen in a chemical reaction before I have to go into the lab and perform it so that I can perform it cleanly, efficiently, and well. The 3, The 3 processes is outlined here, the 3 steps in order. First of all, actually, 4 steps, call it 4. You must start with a balanced chemical equation. You have to be able to write that. That is problem number 1 for most students. When they're asking me for help, the first thing we look at is a reaction. If the reaction is wrong, the rest of it will be wrong. So make sure you know how to balance your chemical reactions. Then it's very simple. You have to be given one mass. It doesn't matter if it's a reactant or a product. One of those substances in the chemical reaction has a mass. You can calculate every other one. Okay? And you'll take that and you'll change that into moles. Okay? Then we're going to compare those moles with what we have in a balanced chemical equation and find the moles of the new stuff that we want, and then we're going to take the moles of the new stuff that we want and multiply by the molar mass to get it into grams. So really it's 3 math steps of divide, multiply, multiply. Let's go right to the example. Here we have a double replacement reaction. Okay, and so calcium phosphate and lithium chloride are going to interact, and I'm going to then, of course, this cation with that anion. So we're going to make some lithium phosphate, and we need 3 of those because phosphate's a -3. Okay. The other product that's going to come out of this is calcium chloride. Okay. And then the balances with the appropriate coefficient, that's going to need a 6. This is going to need a 2. That's a 2 hiding in there. And this is going to need a 3. And now what it tells me in this equation then is that what I have here is 1 mole of calcium phosphate will always, this is no matter where I do it, this is its lowest ratio. 1 calcium phosphate mole will combine with 6 moles of lithium chloride and produce 2 moles of lithium phosphate and 3 moles of calcium chloride. And here's how I set up my stoichiometry. I put a grid together. I have one line that's mass, one that's molar mass, and one that's moles. And I fill out, say from a word problem, everything I know. In this problem, we're going to start with 575 grams of calcium phosphate. And from that, we're going to calculate the grams of everything else, every other substance here. So how much lithium chloride would I need to mix with that, and how much of each product would I get? The other thing I can fill out before I start the problem, once I get my balanced equation, is the molar masses. 3 calcium and 2 phosphate groups. In other words, I have 8 oxygens, 2 phosphorus, and 3 calcium here. All will add up to 310 grams per mole. Okay. Lithium chloride, 1 lithium and 1 chlorine is 42.5. 3 lithiums, a phosphate, and 4 oxygen will add up to 116 grams per mole. Okay. And the calcium chloride, 1 calcium and 2 chlorines will add up to 111 grams per mole. So now I'm just set up really what I have here, grams per mole. Okay. What I have here is the setup to do, really I have 3 separate problems doing the same thing. They all go from the first step. The first thing I have to do is change this mass to moles, and the way I do that is to take this mass and divide it by its molar mass. Okay, and that comes out to be 1.85 moles. Okay, that's step one. That's always step one. Balanced equation, know one mass, divided by its molar mass, get it into moles. Now, I'm ready to go to work with all the others. And this is where the one step, again, this isn't any new knowledge for you. It's just combining knowledge we've had. About the only thing that might be new is what we're calling the mole ratio. Well, I want to figure out, okay, I know that it's a 1:6 ratio. 1 mole of calcium phosphate requires 6 moles of lithium chloride. But I don't have one. I have 1.85. So what's the corresponding number that would be there? Or in math, when they talk ratios, what we're saying is 1 is to 6 as 1.85 is to x. So what I'm going to do is I'm going to take my known moles of 1.85 moles of calcium phosphate, okay, and I'm going to multiply that by a fraction that is called the mole fraction, mole ratio, mole whatever. What it is the ratio of lithium chloride to calcium phosphate. So I'm going to use the coefficients here to set up my ratio, because this we know is always a 1:6 ratio. So I'm going to put the 6 lithium chloride for the lithium chloride on top, the 1 for the calcium phosphate on the bottom, because it is always the coefficient of the one I want over the coefficient of the one I am starting with. Okay, and that's, if you scan back in the video and go to those rules and write those down, that's true. So in other words, what I have here is 1.85 times 6, which is 11.1. That is step 2. So here was step 1, doing the division. Here was step 2, doing the mole ratio. And step 3 then is, if I want to get this number of moles into grams, I got to multiply by the molar mass of the lithium chloride. Okay? And that's really step 3. And 11.2 times 42.5 is 472, rounded to 3 significant figures. Okay? And that's how many grams of lithium chloride I need to go with this. And it illustrates a great point. It's a 6-to-1 ratio of moles, but this is why we can't use grams, because calcium phosphate, with all its molar masses, is much more than lithium chloride. So 6 moles here is only 472 grams, or 11 moles is 472 grams, whereas barely 2 moles are 575. So you can see why we have to work in moles to make the ratio work. Now I can do the same step with this one. Okay, the lithium phosphate. How much is going to be produced? Well, I've already got my balanced equation. I've already done step 1. I know it's 1.85, but now the ratio is 1.85 times 2 over 1. So in this case, for the next one, it's going to be 1.85 times 2 over 1 for this problem here. And 1.85 times 2 is 3.70. Okay. There's step 2 for this problem. And to get to step 3, take the 3.7 times 116, and that's 429 grams. And then I've solved that one. Okay, it's a 9. Okay. Then the final one, the calcium chloride, I can do that also, but now, again, balanced equation, I've already done step 1, I have 1.85 moles. Now the ratio is going to be, let me get the eraser down here a little bit and clean some of this up. Now the ratio is going to change, because now it's a 3-to-1 ratio according to the balanced chemical equation. So now for the last one, it's going to be 1.85 times 3, which is 5.55 moles. That's a 5. The pen's getting away from me on the 5s. Okay. And again, final step is 5.55 times 111 comes out to be 616. So what you can see we've done, sorry about my writing, what you can see we've done, we just started with this one in a balanced chemical equation. We found out how many moles we had. It wasn't the exact number here, but we could use the equation to do ratio math and figure it out. In this 6-to-1 ratio, 1.85 is the same as 11.2 because it's 6 times more. Okay? And that's what I would need to satisfy my 6-to-1 ratio. For this one, then, I would produce 3.70 moles because it's a 2-to-1 ratio, so I'm going to need twice the amount in moles. Notice it doesn't necessarily correspond to math. And in the last one, since it's a 3-to-1 ratio behind the from the equation, then it's 1.85 times 3. So really all you're doing in this mole ratio step is getting the corresponding number that would be equal to what the ratio is here. So this is 1 to 6, that's 1 to 6. This is 1 to 2, that's 1 to 2 with the corresponding number. This is 1 to 3, that's 1 to 3 with the corresponding number. And then the last thing is just to get it into mass. Now, one of the quick checks you can do is if you remember that you cannot create or destroy matter, then if I add my two reactants, they should be relatively close with rounding and stuff, roughly the same mass as my two products because I can't create and destroy. And if I add these two together, that number is equal to 1047. Grams. If I add these two together, that number comes out to be equal to 1045. And I think that's close enough with a little rounding and stuff for my sig figs and my atomic mass to say that's it. But as you look at that example, we did the same things 3 times. It all started with the balanced equation, which is everybody's problem. That's where 99% of the errors are in the first place I go to look. Then I set up my grid. This molar mass will be the second area of problems. That'll be about 0.5%. Make sure that you are adding up each atom into the total. Okay. And then we got that. We found our molar mass. Second step was to multiply by the molar ratio. This is the last little bit of mistakes, is making sure that I put the one I'm looking for over the coefficient of the one I'm starting with. The other little point is I could have just used this one to find that one or that one. Once I have any of these moles, I can use them in a ratio here to find the other. Okay. Anyhow, there's a practice problem. Go over it as many times as you need to understand and compare that to your packet. But that is stoichiometry. Scholar on Eastview, and happy practicing.